Assalamualaikum and very good day to everyone. I am Farhan bin Jamdi, and today I will be presenting about my research project, which is the torrefaction of palm fresh fiber in a fixed bed reactor. So first of all, we'll begin with the introduction. So basically, currently we are being too dependent on fossil fuels and coals in order to generate energy and electricity. Therefore, as we all know that right now, the number of fossil fuels and coals are finite and it will be depleted soon. Therefore, there is a need now for us to actually find a renewable alternative source of energy, and this alternative source of energy can be found in terms of biofuels, which is from the biomass. And these biofuels can be converged from various methods, which is the pyrolysis, combustion, and also gasification. So basically, what are the types of biomass can be used for biofuel? Whereby types of biomass that can be used, it can be consist of woody biomass, waste biomass, and also household waste biomass. And what is the torrefaction is all about? So torrefaction is the pre-treatment step for the pyrolysis process in order to increase the quality of the bio oil. And also torrefaction is the thermochemical treatment of the biomass itself within the range of the temperature 200 to 300 degrees Celsius in an inert atmosphere with the absence of oxygen. And the torrefaction process itself can produce a lower moisture content of the biomass, and it can make the biomass easy to be grind. Alright, next we will move on to the problem statement. So basically, the problem that we have right now is, first of all, is the accumulation of the agricultural waste. As we all know that the palm oil industry itself produces million tons of agricultural waste from the extraction of oil from the fresh fruit bunches. And from the production of 90 million tons of crude palm oil in 2017 itself, 14 million tons of palm fresh fiber are being produced as the byproduct. And second is the inefficient direct use of biomass as biofuel. As we all know that raw biomass itself have high moisture content and low energy density, thus making the biomass itself unable to produce equivalent energy as the fossil fuel itself. The study objective of this research project is, first of all, to conduct the torrefaction of the palm fresh fiber at different torrefaction temperature within the range of 200 to 300 degrees Celsius at different holding times of 20, 40, and 60 minutes in a fixed bed reactor. And second is to analyze the values of activation energy for the torrefaction of the palm fresh fiber using the Torrefaction method. And lastly is to identify the functional groups of the chemical composition of raw and torrefied palm fresh fiber by using FTIR. The scope for this research project is four. So basically, first of all is the biomass. The biomass that is being used for this research project is the palm fresh fiber. And the optimization parameter that is being used in this experiment is the temperature, which is in the range of 200 to 300 degrees Celsius, and also holding time, which is 20, 40, and 60 minutes. And the chemical analysis that is being analyzed in this experiment is the raw and torrefied palm fresh fiber by using FTIR. And also the activation energy will be determined by using Torrefaction method. Alright, so next is the literature review. So palm fresh fiber is basically the one of the byproduct from the extraction of oil from the fresh fruit palm bunch. And the palm fresh fiber itself is typically used as a solid fuel in order to supply heat and energy for the production of the palm mill plant. And the utilization of this biomass for energy source is inefficient due to the high amount of moisture and oxygen content. And next is the torrefaction, whereby the product of torrefied biomass itself will form a brown to black colored solid which contains the low moisture content with the high calorific values. And torrefaction can be considered as the one of the best method in order to improve the quality of the biomass in terms of physical and chemical composition before it can be used as the biofuel. And this is the effect of the torrefaction temperature and holding time on the torrefied biomass. So basically, the summary of this finding from this researcher is that the mass yield of the biomass itself decreases when the torrefaction temperature increases, and also the moisture content of the biomass itself has been decreased when torrefaction process is being occurred. Alright, so for the research methodology, it can be shown in the process diagram in the figure shown, whereby first of all we acquire the palm fresh fiber in the first place. Next is the pre-treatment of the palm fresh fiber, whereby we dry, grind and sieve the palm fresh fiber. After the pre-treatment process, torrefaction process is being occurred, whereby we will optimize the parameters such as the holding time and also the torrefaction temperature. And next, after the torrefaction process has been done, the torrefied biomass will be further studied by using FTIR analysis and also kinetic analysis by using Coates-Rutherford method. And this is the schematic diagram of the fixed bed reactor for the torrefaction process. Alright, so next is the results and discussion. First of all is the effect on the physical changes of the palm fresh fiber. So basically, as shown in table 1, it shows the color changes of the torrefied palm fresh fiber at different torrefaction temperature and holding time. So if you can see at the table shown, the color of the biomass itself actually changes from brownish to darker color, which is black, when the torrefaction temperature actually increase. And these physical changes of the biomass color, which is from brownish to black color in the first place, actually signifies that the biomass itself has a higher fixed carbon content after the torrefaction process has been conducted. Alright, so next is the results for the mass yield of the torrefied palm fresh fiber. And as you can see in figure 1, it shows the mass yield of the torrefied palm fresh fiber at different torrefaction temperature and holding time. And as you can see in the figure, the mass yield itself actually decreases as the torrefaction temperature increases. And at the temperature within the range of 200 to 240 degrees Celsius, the mass yield of the torrefied palm fresh fiber actually decreases slightly. But however, at the temperature of 280 and 300 degrees Celsius, the mass yield actually decreases significantly within this range of temperature. Alright, so next result is the FTIR analysis of the raw and torrefied palm fresh fiber. So we conducted this FTIR analysis which is to identify the functional group that exists on the sample of the raw and torrefied palm fresh fiber. And within this FTIR analysis, the structure of the palm fresh fiber actually changes due to the degradation of the hemicellulose, cellulose and also lignin content of the biomass. And the changes of the wave number within the FTIR analysis actually occurs due to the volatilization and also the dehydration of the biomass when it undergoes the FTIR analysis. And from the figure 2, we can actually, the high intensity and broad peak is shown at the wavelength of 3400 cm, which signifies the OH compound. And meanwhile, at the low intensity shoulder at the wavelength of 2900 cm, we can see there is a CH compound which shows the alkene functional group. Alright, so for the last result of this experiment is the activation energy of the torrefied palm fresh fiber using the Coates-Rutherford method. So as you can see in figure 3, it shows the linearization graph for the Coates-Rutherford method. And from this linearization graph, we can obtain the values in the table, this table 2, which shows the activation energy of the torrefied palm fresh fiber at different holding times of 20, 40 and 60 minutes. And the lowest activation energy that can be obtained from this Coates-Rutherford method is at holding time 60 minutes. We can obtain the activation energy 22.079 kilojoule per mole. And activation energy is actually the minimum energy required in order for a reaction to be occurred, or in this case, which is the torrefaction process. And this trend of degradation of the activation energy value also shows when the holding time actually increases, the activation time will be decreases. And this results of the degradation of this activation energy is actually is a positive impact, because when the activation energy of the reaction is lowered, lesser energy actually is required in order to break the bonds and structures of the biomass in order for torrefaction process to be occurred. Alright, so for the conclusion, the research project, which is the torrefaction of palm fast fiber in a fixed bed reactor, has been conducted successfully, and from the results shown, the color of the biomass itself actually changes from to darker color when the torrefaction temperature is increased, and the mass yield of the palm fast fiber also decreases when the torrefaction temperature increase, and the activation energy of the palm fast fiber actually decreases when the holding time actually being increased in the torrefaction process. And for the recommendation, it is recommended that further studies on the torrefaction of palm fast fiber is needed to be continued in order to obtain better result in this research. For example, investigating new parameters such as the proximate analysis and ultimate analysis of the biomass would be beneficial. And the torrefied biomass also should be used in the pyrolysis-based research study in order to study the effectiveness of the torrefied biomass towards the performance of the pyrolysis process. And that's all from me. Thank you.